Section 2.8, titled Solving Absolute Value Equations and Inequalities. So we're going to look at first what is absolute value and simplifying absolute value expressions. We'll look at some absolute value equations, and then we're going to dive into compound inequalities and how they relate to absolute value inequalities. Absolute value is the distance a number is from 0 on a number line. So if I were to, let's make a number line here. Okay, so if I want to know what is the absolute value of a number, well, notation-wise, absolute value looks like that. You use two parallel bars, parallel lines around the number. This is read absolute value of 3. And what it means is how far away is 3 on a number line? Answer is 3 units. If I want absolute value of -4, that means how far away is -4 from 0 on a number line? The answer is it's 4 units away. Because of the word distance, absolute value always takes on positive answers. Distance is always a positive number. So when we want absolute value of something, that something's always going to come out positive. A couple of numerical expression examples. First of all, absolute value bars act kind of like parentheses in the sense that you need to perform any operations inside them first. So I have absolute value of 36. Here I'm going to multiply minus 48. I keep going, absolute value of -12. And then once it's down to a single number, now I can take the absolute value of -12, which is 12. Next one, I'm going to work inside absolute value bars first. So 12 plus absolute value of -5 minus 3. Absolute value of -5 is 5. And now we can work left to right. 12 plus 5 is 17. Minus 3 is 14. Okay. So really just sticking to order of operations, think of absolute value bars as parentheses, but don't evaluate, don't change minus signs to pluses, change negative numbers to positive after you've got it down to just one single number. Let's next do a couple of examples of solving absolute value equations. The first thing that we're going to do when solving an absolute value equation is isolate the absolute value. I'll say the absolute value part. In other words, get the absolute value all by itself. Okay, so to do that, I'm going to add 4 to both sides, which will give us absolute value 3x minus 1 equals 16. Okay, that's the first step. Second step is to write 2 equations that are implied by the absolute value. Okay. So what do I mean by that, right? 2 equations implied by the absolute value. Well, for example, this particular problem, I'll just do it right over here. The absolute value of what number is equal to 16? Well, the answer would be that the absolute value of 16 is equal to 16, and the absolute value of -16 is equal to 16. So, in other words, the stuff inside the absolute value bars, the 3x minus 1, could be equal to 16, and the 3x minus 1 could be equal to negative 16. Okay, so really we're just kind of splitting this up. We're taking the 16 and its opposite, negative 16, writing two equations. Okay. Once we've done that, the last step is then just to solve the equations. Okay. So let's do that. I'm going to skip some steps I'm going to skip writing the steps. So this is going to be, I add this one over, so I get 3x equals 17, divide by 3, we get 17 thirds. Here I add the 1 over, so we get 3x equals negative 15, divide by 3, we get x equals negative 5. Okay, another absolute value equation example. First thing we're going to do is get the absolute value by itself again. So here I'm going to multiply by 3. Well, that gives us absolute value 4 minus 7x equals 6. So that means the 4 minus 7x can be equal to 6, because that would come out to be 6, or it can be equal to negative 6, because absolute value of negative 6 would be 6. And now we solve both of these equations. We're going to minus 4, so negative 7x equals 2. Divide by negative 7, we get negative 2/7. Here we minus 4. Get negative 7x equals negative 10. Divide by negative 7, we get positive 10/7. Here's another couple of examples. I'm going to go ahead and work them for you. This would be a good point in the video if you want to pause and work on your own and then fast forward to the end and see the answers. You could do that too. First one, the absolute value is all by itself. So we're going to go ahead and split this into two equations. 2x plus 3 equals 9. 2x plus 3 equals negative 9. So here I subtract 3. We get 2x equals 6. So x equals 3. Here I subtract 3, so 2x equals negative 12, so x equals negative 6. Not much to that one. The second example is one that a lot of students are going to miss the first time because there's something uniquely different about it than the other problems we've seen so far. I begin by moving this 13 across. Got to get the absolute value by itself. So absolute value 5 minus 2x equals negative 6. Absolute values by itself and will equal a negative number. That we haven't seen yet. So let's think about what that means. Is there the absolute value of any number that comes out to be negative? And the answer to that would be no, because we said at the outset of this that the absolute value of all numbers come out to be positive. So it's not possible. It's not possible to find a number that fits this description. Therefore, this equation at this point has no solution. Has no solution because that's a negative number. Now I want to shift gears and look at some inequalities. A compound inequality is when we have two inequalities. Let's say connected with an and or statement. So there are two types. They're listed here. A disjunction uses or. A conjunction uses and. Okay, so two types of compound inequalities. And we'll go through a variety of examples and then connect it to absolute value as well. First example says 6y is less than 24 or y plus 5 is greater than or equal to 3. So the first thing I'm going to do is just solve them both. So divide by 6, we get y is less than 4, or I'm going to minus the 5 over, get y is greater than or equal to, that's going to be negative 2. So let's create a number line. Just go and put 0 in the middle. Alright, so we would like to shade or show on our number line all the numbers that are less than 4. Shows that. Or all the numbers greater than or equal to negative 2. That would be these numbers. So, solutions to this compound inequality can be here or here. Since it's an or statement, we've shaded both directions here. They've overlapped. And we're saying solutions can be here or here. In other words, solutions can be everywhere. So our, in fact, entire number line is shaded. This open circle gets filled in with the shading going to the right. Our solution to this is negative infinity to positive infinity. Now, I will say that's pretty unusual to have that happen. Most of your or statement problems, you're going to see 2 points on a number line like this, and they're going to shade away from each other, not towards each other, as we just saw. But this can happen, so here you go.